You ever get stuck on a problem that just feels impossible? The kind where every brainstorm ends with the same old, tired ideas? Well, what if I told you there's a systematic framework out there for generating real breakthrough solutions? A structured way to be inventive, basically on command. All right, let's dive into this seriously powerful tool for your toolkit. It's called TRIZ.
So here's how we're going to tackle this, just like a proper strategy session. First up, we'll nail down the core challenge of innovation. Then, I'm going to introduce you to the TRIZ framework itself. After that, we'll do a deep dive into something I call the 4 innovation lenses. It's our structured way to make this whole thing actionable. Then, we'll build your personal action plan. And finally, we're going to completely reframe how you even think about inventiveness.
Okay, so let's start with a feeling we have all had. You hit a wall. You're staring down a super complex problem, and all the standard, by-the-book solutions, they're just not going to cut it. This right here is where innovation so often just grinds to a halt. Seriously, think about it for a second. When you are truly, deeply stuck, what is your go-to move? For a lot of us, probably most of us, the default strategy is something that looks a whole lot like just brute force. Yep, good old trial and error. We try one thing, it fails. We try another thing, that fails too. It's an approach that feels like you're doing something. It feels productive. But honestly, it's incredibly inefficient. It's unpredictable. It relies way more on dumb luck than on actual skill, and it just burns through your resources and your team's morale. There has to be a better way, right?
And that better way is TRIZ. This is the powerful, structured alternative to just, throwing stuff at the wall and hoping something sticks. This is a system, and it's designed to guide you straight toward an inventive solution.
So TRIZ is actually a Russian acronym, and I'm gonna try this. Teoria Решения изобретательских задач. It means the theory of inventive problem solving. It was developed way back in the 1940s by a Soviet engineer, Genrich Altshuler. And what he did was he analyzed thousands and thousands of patents and discovered that these huge technological advancements, they weren't random. They actually followed predictable patterns. And TRIZ is just the result of him codifying all of those patterns. The whole philosophy behind TRIZ is so brilliantly simple, and it's perfectly captured by this old saying. Altshuler's big insight was that for pretty much any problem you're facing, it is highly likely that hundreds of other smart inventors have already solved a very similar underlying problem, just in a totally different field. The key is to learn from them and adapt what they already figured out. Now, at the very heart of the TRIZ toolkit are what's known as the 40 inventive principles. And I know what you're thinking. 40? 40 principles? That sounds like a lot. And you know what? You're not wrong. At first glance, it can feel a little bit daunting. But don't worry, we are not about to just list all 40 of them. The secret to using any powerful framework is to organize it, right? So we're going to give you a clear, structured way to make these 40 principles digestible, memorable, and, most important of all, actionable. So what we've done is group the 40 principles into 4 strategic lenses. And you can think of this as a MISI framework, that's consultant speak for mutually exclusive, collectively exhaustive. But really, all it means is that each lens is distinct and unique, and when you put them all together, they cover all the bases. This ensures you're attacking your problem from every single critical perspective. Our very first lens is all about the physical stuff. It asks a simple question. Can we solve this problem by changing the object's physical form, its layout, its dimensions, or maybe how it's divided up? It's about thinking like a sculptor or maybe a systems architect. So, check this out. It's fascinating how these simple physical changes translate into huge business strategy. Take segmentation. The guards on hair clippers? Perfect. Simple example. But in business, this is the entire idea behind modular product design. It lets you build your own custom car or computer. In tech, it's the whole concept of microservices, right? Breaking a giant application into smaller, independent parts. The nested doll principle. It's not just for stackable chairs. It's the logic that makes global logistics even possible with those standardized shipping containers. And moving to another dimension, a spiral staircase saves floor space. In business, that's like shifting from a brick-and-mortar store to an e-commerce platform. You're adding a digital dimension that completely changes your footprint. All right, let's move to our next lens. This one is all about mastering process and time. Here, we're not really changing the what, we're changing the when and the how. So the question becomes, can we solve the problem by altering the sequence, the timing, or the rhythm of the actions? And this just brilliantly shows how messing with time creates a ton of value. Preliminary action, the pre-drilled holes in IKEA furniture, that is a classic.
It shifts the effort and time to make the customer's life way easier. Periodic action turns a constant, boring hum into an urgent signal, like a fire truck siren. In marketing, this is A/B testing. You make intermittent changes to a website to get data, instead of having one constant design. And this principle of skipping is so cool. Sometimes, the only way to get through a really dangerous or complex process is to just go at extreme speed. Think about agile development sprints. You're not solving every single problem up front. You're moving incredibly fast to bypass that paralysis that comes with traditional project management.
Okay, our third lens. This one focuses on elegance and efficiency. It really challenges us to simplify our systems and to get creative with the resources we already have, especially the ones we might be overlooking, or, get this, even the ones we see as problems. So this contrast is absolutely crucial. The traditional engineering mindset is almost always to add more, a bigger motor, a new sensor, more code. The TRIZ approach is fundamentally different. It asks, wait a minute, what if a problem is actually a solution in disguise? How can we turn this liability into a real asset? Now look at these through a business lens. Blessing in disguise isn't just about composting. It's the foundation of industrial ecology, where one factory's waste heat becomes the energy source for the factory next door. It's about turning customer complaints, a supposedly harmful factor, into your most valuable source of product feedback. Self-service is the engine behind huge industries. It's not just phone menus, it's online banking, self-checkout kiosks, all these SaaS platforms that empower users without ever needing a sales team. And cheap short living is a core strategy. In tech, we call this the minimum viable product, or MVP. It's a deliberately simple version of a product you launch just to test the market, replacing a super long, expensive development cycle. And that brings us to our final and honestly most mind-bending lens, changing the system's rules. These principles are for when you have to fundamentally alter the entire game. They solve problems by challenging the core assumptions of how the system is even supposed to work in the first place. These principles, they often lead to the truly disruptive innovations. Anti-weight literally defies gravity. The other way around is a classic disruptor move. Instead of customers coming into the store, the restaurant comes out to the car. Netflix did this by mailing DVDs, completely reversing the video store model. And mechanic substitution is transforming our entire world, replacing clunky keyboards with voice dictation, physical credit cards with our phones, manual data entry with optical character recognition. This is about changing the very physics or logic of the problem. Okay, so we've explored the four lenses, we've seen some of the principles in action. Now for the big question. How do you actually use this stuff? Let's switch gears from theory to a clear, practical methodology. It's a simple but really powerful four-step process. First, step 1, you get laser-focused on defining your specific problem. Step 2 is the abstraction part. You find the general, universal problem that yours is just an example of. Then, step 3 is where the magic happens. You identify which of those 40 principles were literally created to solve that general problem. And finally, step 4, you bring it all back to reality, adapting those general solutions to fit your specific context. It's a repeatable loop. Define, find, identify, and apply. All right, let's pull back for the conclusion here, because the real power of TRIZ, it goes way beyond just solving problems. It fundamentally challenges this romantic and frankly unhelpful myth of the lone genius just waiting around for a random flash of inspiration. For centuries, we've bought into this eureka moment, the idea that innovation is unpredictable and is reserved for a special few. TRIZ just completely flips that script. It proposes a system of innovation, a structured, reliable, and repeatable framework that makes inventive problem-solving accessible to literally everyone. It basically turns creativity from an art into a science. And this right here, this is the key takeaway. Innovation isn't always about creating something from nothing. Way more often, it's about seeing the connections that everybody else misses. It's about understanding the universal patterns of problem solving and then systematically applying them. And TRIZ, well, it gives you the map to do exactly that. So, as we wrap up, I just want to leave you with this one thought. The next time you face one of those impossible problems, ask yourself, are you just going to wait for a lightning strike of inspiration? Or are you ready to pick up your tools and actually solve the equation? With a framework like TRIZ, you're not just hoping for a breakthrough, you're engineering one.